So we're told that building has 6,000 square meters of floor space, and the question is how many offices? So number of offices in the building. Statement 1 says exactly 1/4 of the floor space is not used for offices. So 1/4 of that is 1,500, which means 4,500 is used for offices. But we don't know anything about the size of the offices, so we don't have any information on the number. So 1 alone is insufficient. 2 alone says there are exactly 20 executive offices, and each of these occupies 3 times as much floor space as the average for all of the remaining offices. So we have 20 executive offices. Again, we can actually rule out 2 alone because we don't know how much is not used for offices, because that came up in statement 1. So 2 alone is insufficient. If we look at 1 and 2 combined, now we have a total space that's occupied is 4,500. They tell us there are exactly 20 executive offices. And let's say each one occupies F square meters. And it says each of these occupies 3 times as much floor space as the average for all the remaining offices. Now, they could be all of different sizes. So let's say that average is M for the remaining offices. So that's the M square meter. So here, F is going to be 3 times M. And that average M is going to be the total area of those offices divided by the number. So that area is M times N. And there are 20 executive offices, so that area is going to be 20 times 3M. I'm trying to write everything in terms of this average square meter that these other offices combine, plus M times N. What I don't know is the number of these other offices, and that's equal to 4,500. And that I can't really solve for, because the total number of offices in the building would be 20 plus this N, which I can't solve because I still have another variable M. So combined, still insufficient. The answer is